Welcome to Validas video tutorials. In this tutorial we will give you a brief introduction into our toolchain analyzer, which is our model-based approach to qualify toolchains. In a safety-relevant environment we do not only need safe software but also safe tools. In this example we have a toolchain that has no error detection mechanisms, and by that errors can get into the safety-relevant product, such as a car or an airplane or something else like a train. So that errors do not get into the final product, we need certain detection mechanisms how to avoid possible errors to get into the final product. And for that we need to analyze the toolchain and describe how the tools interchange artifacts and how we can test and introduce detection mechanisms that finally we can prove that there is no potential error getting into the final product. For that I will now open up the Validas Toolchain Analyzer to understand this procedure a bit better. To give you a first introduction into the process, I prepared a little model where we can start a bit of modeling to understand how we can qualify a toolchain. Now we open up a model file, and what we get is a tree view of our model. In this model I have a compiler which needs to be qualified, and this compiler has modeled certain features which are contained in a compiler, like we have an sampling feature, a compiling feature, linker, and so on. And these features have as well sub-features. So this is our tree view where we can see and model our reference model for our toolchain. So there we have first of all our basic tree, which holds our entire toolchain, and in this toolchain we have certain tools, like here it's a single compiler, and this single compiler has again sub-features which we did model, and by that we describe the components of this compiler. This compiler is exchanging software artifacts, which we describe in this artifacts components, and with these components we can see how these features exchange software artifacts between each other and where there are potential errors getting mitigated by another software feature of the compiler. When we click on one feature, the property view opens up and we can see certain attributes which we can give this feature. In the upper area we have basic naming attributes, like we can give the feature a name, like a sampling, put a description, a short description, and also give it a certain ID when it is related to certain requirements. And finally we can say if this tool feature has an impact into the safety, and in this case it's true. When we are not sure, we can give it a other attribute like is assumption, and that marks this software feature as assumption, and then it becomes rather irrelevant for the qualification and gets stroked out. Next I will give you an introduction to the colors. As you already saw that now this feature component, by getting stroked through, it changed its color. When it has a yellow hook, which this means this feature has somehow a mitigation which is already attached on the name of the feature that this feature is mitigatable. And red features that are marked red are uncovered errors that can get into the final product. But because we now have only modeled features and not use cases, which are the goal for qualification, this tool is at the moment black, which means because we have no use cases, there's nothing getting into the final product. Later on, we will model some use cases where we can see how the tool changes its color and either gets green for a safe qualification or remains red when there are potential errors left inside the toolchain that need to be covered by any kind of tests like unit tests, which is performed by our toolkit. In our bottom views, we have other views like data flow, where we can see how the data flows from an artifact to features and where it comes from. So this feature has an artifact input that is assembler source code, and it comes from the feature compiling and feature pragma, which both create preprocessed source code. And the assembling feature then creates outputs. You can see here. These artifacts are the output of the assembler. So we have modeled messages, we have modeled object code, which is going finally to further processes into the linker. So here we can see how the artifact flow is getting from other compiler features through the assembler feature and to other post-processing features like the linker. And it's not only going to from the next instance, but also further instances can be viewed inside this data view. This is the basic overview of the Toolchain Analyzer. There are lots of other functional features inside the Toolchain Analyzer, but that's it for now. And now we can start to model use cases, and then we can see how our toolchain is getting analyzed and if there are remaining errors found or our tool is finally qualified entirely. First of all, when we open up our model, we can see a tree view that is showing our entire model. Starting from the root, we have a toolchain that holds certain tools. In this example, we have a single compiler, which is again modeled in certain features, like assembling, compiling, linking, preprocessing, and so on. These features again can be split up in subfeatures, like we can see here. We have in this assembler features like assembler command line options, encoding, and so on. And inside these features, we can model potential errors, which we can see here. Either these potential errors can be mitigated, then they become a violet color, or they are not covered, then they remain red. We model now our toolchain in that way that finally we can detect all the errors by either mitigations or unit testing, then finally we can cover all our use cases at the end to qualify our product. Between these tools, we exchange software artifacts. In this area, the software artifacts which are exchanged between either tools or certain features inside the tool, and by that they have either a green color or a violet color. The meaning of these colors are a bit different from the meaning above. A green color always means that this artifact is safe or this feature is safe. In an artifact context, it rather means that this artifact has inputs and outputs. If an artifact has either no input or no output modeled, we can see that this artifact then turns into a violet color artifact. So in this example, we can see in our data flow, which shows the artifact flow between features and artifacts, that this artifact has inputs but no outputs. When I click on a green artifact, we can see that this artifact has outputs and inputs. On this side, we have the attribute view. And in this attribute view, we can see all our related attributes, which describes either the artifact or certain features. These certain features describes names, IDs and descriptions as basic attributes, but also more complex attributes like connected inputs and outputs, use cases, states, and also some others which we can expand in our extended view. When a tool has an impact for the safety, we can mark it with this impact hook, and then it becomes relevant for the tool safety. In this case, for instance, we have the pre-processing feature that is marked with an impact, and then it has an impact on this tool safety. When I unclick this impact hook, we can see that this feature is not safety relevant, has no impact, and then becomes green. But as we know that pre-processing is safety relevant, and pre-processing other artifacts that are finally can get into the tool, we have to mark this with an impact. If we're not sure if this has an impact, we can say this is an assumption. But then it gets stroked through, and then also turns its color into a black neutral color. Also, we can see on our data flow that this feature processing artifacts source code and finally creates pre-processed source code. And this pre-processed source code finally goes into other features, like in compiling and in feature partner. But then when doing the compilation, it finally creates artifact assembler source code, and this artifact assembler source code again gets processed further in the assembling feature, and then finally the object code goes into the linker, and then finally the linker processes it further, and so on. So to make a qualification, we first have to model use cases for which we want to qualify this tool for. So therefore I will model some use cases. Now we'll start to create some use cases. For instance, we have a use case, compile application. Also the use case, compile library. When you create these use cases, or also The same thing is on other modeling objects. First of all, they become gray. Gray means that they have neither inputs nor outputs, and further also no features. So it's an empty use case, and therefore this use case is marked gray because it has no effect at the moment. But because there is a certain task in this use case, we have to describe this use case based on our given features. By that, we assign features to our use case. We can do this with this little link button. In our case, we choose the bottom features, which is, for instance, our assembling feature, and with Control key pushed down, we assign other features to our use case, and well, safety guidelines. And now we have these features assigned to our use case, and by that our use case is processing our artifacts via the given features. Because we have features assigned, we get errors which are inferred by our features, like the inferred error include, not included, and so on. And these potential errors finally did not yet got mitigated by other tools inside the toolchain. So when finally compiling our application, we need to ensure that these inferred errors finally get either tested or mitigated by certain unit tests. When you finally assembled our use case with all these features, then there are remaining errors which get inferred by our features. To finally cover these remaining errors, we need to create tests. First, we start with a test suite. And for this test suite, we need unit tests. For that, we assign our use case, compile application. And also the linked error, which are remaining. In this case, it's include. I finally now classified my tool where I modeled all potential errors inside some unit tests, and we can see that all our inferred errors received a green check mark. There's one inferred left in this inferred error toolchain, but this is due to other applied tools in this use case which mitigate our potential error of wrong output assembler code. And therefore, finally, our tool receives a green check. When we have this result, we can now proceed further with unit tests which get performed with our QKit wizard, which executes our automated testing unit that executes the tests and returns the report into the model. When we return the report into the model, we can create further documents which build on the classification document. But first we want to create the classification document, which gives a comprehensive report of our toolchain. Therefore, we choose a certain document path where we want to generate our classification document, and then we create a certain path where we want to put our certification document, and then we finally generate our report. Now we receive this document, the Word is getting opened automatically, and we have now a comprehensive documentation of our toolchain, where we have either feature described with certain artifact inputs and outputs, and also other attributes related to the functional safety standards. We also receive diagrams which describes our toolchain, and also sub-features which get described in their functionality, how they handle artifacts and process them further to other features, and also mitigations are modeled inside these graphs. So this branch is showing our potential error flow, which gets checked by a mitigation inside the safety guidelines for compiling. And these safety guides for compiling avoid that this potential error could pass further into the toolchain. There are several features listed here where we can see exactly how their artifacts getting processed further and how the potential errors inside this toolchain get mitigated by either tests or mitigations. That's it for now. Thank you for watching our toolchain tutorial.